Example 3, you must order a new rope for the flagpole. To find out what length of rope is needed, you observe that the pole casts a shadow of 11.6 meters long on the ground. The angle of elevation of the sun is 36 degrees 50 minutes. How tall is the flagpole? Let's start by drawing a picture. Okay, so we have a flagpole, and then we have the sun, which is casting a shadow on the ground. So here we have a shadow of the flag. Okay. We want to know how tall is the flagpole. So I'm going to call that height x. It says the shadow is 11.6 meters long. So that would be the horizontal distance. And then it says the angle of elevation of the sun. So typically, a lot of people will want to put that angle up here somewhere because that's where the sun is. But angle of elevation is from a horizontal line up. So we look for our horizontal line. That's this line. It's not going to be this angle because that's 90. It has to be this angle. This is the horizontal line, and we are rotating up to another line. That's 36 degrees 50 minutes. So angle of elevation, horizontal line, rotating up. We also can think of that as standard position, because remember, in standard position, the angle has to come from the x-axis. Okay, so we have everything we need, and now we want to solve for x. X is the opposite side of the triangle. And then we have 11.6 is the adjacent side. And so we think about which trig function uses opposite and adjacent. Is it sine, cosine, or tangent? And that would be tangent. So tangent of the angle equals the opposite side over the adjacent side. And then we're going to isolate x and solve. So we're going to multiply 11.6 to the other side. Okay. Then on your calculator or online, you're going to want to make sure you change the minutes into degrees by dividing by 60. Okay, and that's going to be 5/6. 0.833 repeating. And then go to your calculator and type all that in. Make sure you're in degree mode. And my calculator gives me 8.688, which you can round to 8.69. And units, this is meters. And does it make sense in the context of the problem? We're talking about meters. We're talking about a height of a flagpole, so it's not going to be like 1,000 meters or anything crazy. This should make sense. Example 4, an observer 80 feet above the surface of the water measures an angle of depression of 0 degrees 42 minutes to a distant ship. How many miles is the ship from the base of the lighthouse? And note a mile is 5,280 feet. So when we look at this picture, they went ahead and marked the angle of depression for you, which is nice. So angle of depression is also from a horizontal line, but it depresses, so it rotates down, where angle of elevation is from a horizontal line and rotates up. So that's kind of the difference between the two. An observer 80 feet above the surface of the water, so that is up here in the lighthouse. This is your 80 feet. So the picture is already drawn. Angle of depression is 0 degrees 42 minutes, and they went ahead and marked that. So that's up here, that angle there. To a distant ship. And how many miles is the ship from the base of the lighthouse? So they want to know this ground distance or this horizontal distance here. Now, the angle that they give us is outside of the triangle. We want one of the angles that's inside the triangle. So think about how might we find either that angle or that angle. And we're assuming that this angle is 90 for a right triangle. So you might be thinking that up here, this is 90 degrees. So you could do 90 minus 42 minutes to get this angle up here. Or you could use your geometry skills and notice that these are two parallel lines because they're both horizontal with a transversal cutting through them. And so we have alternate interior angles. And so this angle up here is congruent to this angle down here. So this angle down here is also 0 degrees and 42 minutes, which doesn't take any work or subtracting. So going from there, let's go ahead and start to solve the problem. So 80 is my opposite side, x is my adjacent side, and so we're going to be using tangent. So tangent of your angle equals the opposite side over the adjacent side. We want to solve for x, so we're going to need to take x to the other side, multiply x over to your tangent. Okay, and then we want to isolate x, so we're going to divide tangent over. Okay, now we're going to want to type that in, but first we're going to want to change that into degrees. So take your minutes and divide them by 60. And when you do 42 divided by 60, your calculator gives you 0.7. So you've got 0 degrees and then 0.7, which is 0.7. So you can change the problem to this, and now type in 80 divided by a tangent of 0.7. And so you get a really large number, which could be crazy, but when you consider the context of the problem, we are talking about a boat that is really far away. So we need to think about our units, though. The observer was 80 feet, so this 80 I used was in feet. So that means the measurement I just found for the ground distance, this x, is also in feet. So this is feet. And it should make sense. It should be really big. But the question asks how many miles. So now we need to convert that and do some dimensional analysis. So we want miles, we want to get rid of feet. So I want feet on the bottom and I want miles on top. That way the feet unit will cancel. Then we want to put our conversion. 1 mile is 5,280 feet. 1 mile is 5,280 feet. So that means we're going to take that and divide by 5,280. And that leaves me with 1.24 miles.